Hello, and welcome to the latest How to Code a Game Like Minecraft in Unity video. I apologise up front. This video was supposed to be on how to do the cross-trunk lighting and the smooth lighting and all that. A few of you voted on it in a poll that I put up on the YouTube community thing. The people in Discord know what's been going on, but basically the universe has decided that it doesn't want me to make this video just yet, and I do need to upload another video because, let's face it, I can't go weeks and weeks without uploading a video. So I'm just going to get this one done. We're going to cover basic biomes, and then after that, the next Minecraft video will be finishing off the lighting system. Apologies for that. Let's go on with this one. So just quickly before we get started, apologise for not doing this in the last video, but I really should have put a bool on the animated chunk loading thing that we did in the bonus video so that you could easily turn that on and off. So if you didn't follow that video, you can ignore the next 30 seconds or so. But we're just quickly going to script, going to world, and we want to slide down to our settings. And we will put this in, I guess performance will be fine. And we'll just say public bool enable animated chunks. And then if go into our chunk file, and then in the bit where we add the component, we'll wrap that in a if statement. So if world dot settings dot enable animated chunks. And then finally, we'll just go to our settings file, and we should be able to just put at the end here a comma, enable animated chunks, and we will set that to false for now because we don't need it while we're doing all this testing. Now, if we go into world and we look at our settings, we should have enable animated chunks. I'm going to set that to true, and then you see it's set to false as soon as the game runs because it's pulled that information from our settings file. So that's that done. Now let's get into the biomes. So the first thing we're going to need to do is we're going to need to create some biomes. Right now we just have the one, which is we just called default, and it gives us like grassy land with trees. So we're going to need to make some changes in order to make some biomes. But the first thing we want to do is we need to slightly modify the way we do structures, which is at the minute is just doing trees. So let's go find our structures script, and we're going to create a new public static queue, and it's gonna be voxel mod, same as the other one, and we're just gonna call this generate major flora because we're just gonna use it for things like trees and in a minute cacti. So this wants to take an index. I'll show you what the index is for shortly, and then the rest of it we'll just copy from here because it's basically the same thing. And then it's going to be a switch, which will take in that index value. And then depending on the index value, it's going to call one of these. Well, I say one of these. Right now, we only have the one, but there will be more than that. And that's how we're going to call structures in the future. And then if somehow we end up passing in a value that is not part of this, we don't have a thing for it, an index or a function ready for it, then we're just going to return an empty queue. That way there's no errors, and it's going to try and add an empty queue to the queue, which doesn't add anything, so it can just carry on going as normal. So now I want to go over to our biome attributes, and we're going to change this to major flora because depending on the biome it may not represent trees. And then we will also change all references to trees, just so things make a bit more sense in the code. Max height and min height we'll just get rid of the tree part for now. And then if we go into our world script, we should have a bunch of errors somewhere. There they are. So just fix these. And now we're not just calling for trees regardless of what it is that we actually want. And now the other thing we're going to do is we're going to have a bool in here. Public bool place major flora, which we will set to true by default. And as you may have guessed, this is going to give you the option to not have it place anything like this in a particular biome. And I don't know if I'm using the word flora correctly. I'm not a scientist, but hopefully it makes enough sense. So what we're going to say is here, where we check if the Y position is at the correct height to be placing flora, we're just going to say and biome dot place major flora. So now we're only going to be placing it if that is set to true in the biome itself. So the next thing is, right now we are placing grass and dirt blocks regardless of what the biome is, and obviously we want to be able to change that depending on the biome. So we're going to put two values in here. They're not floats, sorry, they are bytes, and they're also public. And we'll call the other one public byte subsurface block. Now remember, the way I'm doing things here isn't meant to show you the 100% everything, every tiny little detail on how to make Minecraft. I'm just trying to show you how to get started on it. So this is only covering the block that is on the very top of the terrain and then the blocks that are just underneath. Right now it's like one grass block, I think, and then 3 dirt blocks underneath. That's these 2 blocks. Surface is grass, subsurface is dirt. We're going to leave stone as it is. If you wanted to change things about a bit and have more layers, I think I've shown you enough to be able to figure that out by yourself. I have faith in anyone watching this video that they'll be able to figure that out. So if we go back into our world and our get voxel function somewhere here, right? So this is our grass block. So we want to change this to biome dot surface block, and then we want to change this one to biome dot subsurface block. Then if we go back into Unity and we find our biome, we just want to set those values to make sure we actually get the blocks. Otherwise they'd all be air. So surface block was 3, I believe, and subsurface block was 5. If I just quickly run that, hopefully it still works. So there we go, we have our surface blocks. And if I dig down here, it's all dirt. And then we can just test that by changing that to, I don't know what these blocks are, but we'll just put 6 and 9. So 6 is wood blocks, and then underneath we have cobblestone. So that's how that works. We'll just change those back for now. Now back into our world, we want to slide up to the top here, and where we have this public biome attributes, we want to change that to an array, and we're going to call that biomes. And then we're going to go back down to our get voxel function where we should have some errors. Yeah, just before the basic terrain pass, which is where we're going to put our, we'll call it biome selection pass. We're going to create a biome attributes which we'll call biome to save all these errors, and then we're just going to say it to biomes, and right now we're just going to put O. Obviously we'll be changing that so it actually selects something shortly. And we'll go back to our world and we'll just put our default biome in there for now. Okay, so we're just going to rename this biome to grasslands. I'll change that name as well, though it's not particularly important just yet. And then I'm going to duplicate it and create another one. So we'll just call this one desert. And if you give me a second, I just need to check which block is sand. So sand is 1, 2, 3, 4. So sand is ID 4. So in the desert biome, I'm going to set both the surface and the subsurface block to 4. I'm going to turn place major flora off, and then go back to world, make this 2, drag desert in there, and then go back into here and change this to 1. Sorry if I did that a bit too fast. So I just I increased the size of the biomes array, added desert to there, and then changed the biome selection here to 1, which is the second item in the index in the array. So now we should have a desert instead of grassy lands, and there's no trees because I turned major flora placement off. And again, the lighting thing we will fix. I'm sorry about that. But desert's a bit boring if it's just sand, so we could do with some cacti. So let's just go into our structure, and we're going to basically copy this, and we're going to call it make cacti. We're going to get rid of this part because this part is what deals with the leaf blocks, and we're not using leaf blocks. And then everything else is basically identical with the exception of this number here. This number is telling it what block that we are setting this current position at. Now at the minute we don't have a cactus block, so let's fix that. So I've already taken the liberty of adding the cactus textures to our texture map. That obviously will be in the download link with the video. I'm not going too crazy with adding blocks to this yet because we are going to do a little bit more work on our block data, a block types system. So that's why I haven't just gone ahead and thrown the whole texture map in there, because we are going to work on that a bit more. But for now, because we want some cactuses in our desert, some cacti in our desert, I've just added these 3 textures. So now that we've got them, we can go into Unity and into our world, and we can add 2 more block types. Actually, let's make that 1 more block type. Cactus. We want the transparency to be 0. Haven't got an icon for it yet, but again, we'll fix that. If I just pull up our block atlas again, so we can see that the cacti textures are 17, 18, and 19 in the ID positions, because it's 0 to 15 on there, 16 is the leaf block, and then 17, 18, 19. For now, we're only going to use 1 block, so we're only interested in 18 and 19. 18 for the sides, 19 for the top and bottom. So 18, 18, 19, 19, 18, 18. And then just because we're here already, I'll add another one which should copy those same values. And that one is going to be called cactus top. And the only difference is that the top is going to be 17, although we are not going to be using that at the minute. The cactus block is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then we want to set this to 12 instead of 6. And then up here we need to account for cacti. So case 1, return. In fact, let's just copy this. Make cacti. Now in our world script we need to also use this. So instead of calling, where is it? Instead of calling here make tree, we're going to go back to structure and remember what I called it, generate major flora. And then obviously we need to give it an index. And then for the index, we're going to go over to biome attributes and we're going to put an index in here. So public major flora, give it a semantic name. And then in here, we just need to say biome dot major flora index. So now let's go back to our 2 biomes and we should have an option here. So for desert, that's going to be 1. And then grasslands obviously is trees. So that just stays at 0 because that's the first option in the array. So let's change that to place major fauna true. And we'll change our max height to, let's see, we'll go between 4 and 2. And then also I just want to go in here and change this offset value so it's not using the same offset and scale as the trees. So it doesn't really matter what it is. I'm just going to go that. That's fine. And for scale, I don't know, 2. So let's just see what that gives us. Okay, so the cactus placement is working, but for some reason we've only got a lot of single block high cacti. So let's just change that. We'll set that to equal the height as well as... Right now it's set to go between 1 and less than height, which means it's essentially going between 1 and 3. Instead of 1 and 4. So we'll make that equals, and then also we'll increase this to 5. So now we have some cacti that are actually taller than 1 block. And again, this, like I say, I'm not trying to show you exactly how to do everything. I'm just trying to show you enough for you to be able to run away with it and do your thing. So we have, you know, the makings of another biome, but now we need a way of implementing that. So if we go into our world and we go into our get voxel function and find our biome selection pass that we created earlier on. Now what we can't do is this. So let's just say we set int index and then we say if noise.get2d perlin new vector2, and then we pass in posx and posz from the value that the voxel that we pass into the get voxel script, and we give it a random offset and a scale of 2, and we just say if that is greater than 0.5f, index equals 0, else index equals 1. And then we move this down here, and instead of setting it to a particular number, we set it to index. So what this is going to do is it's going to do a noise sample check like what we do to get the height of the terrain and things. And then it's going to say if it's less than 0.5, it's going to be 1. And if it's greater, it's going to be 0, so grass or desert. Now here's why we can't do it that way, or why it's not that simple. And for it to properly demonstrate this, I just need to change these values here just a little bit. So I'm going to make that 0.55. And the reason for that is it needs to generate different terrain for me to properly demonstrate why this won't work. And terrain height we will make, I don't know, 18. So this is why we can't do it this way. Now as you can see, Well, for one thing, the biomes are very small. Each one of these patches of Greenland is technically a biome. That's just a scaling issue. That's easily fixed when we do the proper code. The problem we have is the heights. So because we've got it generating different terrain, the biome at this particular point here is this high, whereas the desert biome at that particular point is this high, which obviously causes a problem. So we need to fix that. That's why we can't just simply say, is it this biome or is it that biome? So let's close that. So the first thing we're going to do is this solid ground height in the top corner here. We need to get rid of that. So if you remember, the way we did this is the solid ground height is basically that is going to be solid no matter what is going on with the terrain generation. It's always going to be solid up to that amount, so 42 blocks. And then this height above it, the terrain height, that is going to be from wherever the solid ground leaves off to that is the maximum height. So 42 plus 18 is the maximum height the terrain can be for this biome. And then the purling noise works within those 18 blocks and gives us undulating terrain. Now we can't be having this 42 being different between biomes. It needs to be the same for the world across. So if we're going to have it 42, it needs to be 42 regardless of which biome we're looking at. So we're going to get rid of it in here, and then we'll go back to world, and here will do. We're going to say int solid ground height equals 42, and we can put that somewhere better at a later date, but for now it'll do that. And then wherever we use it, there is an error somewhere. We can just delete the biome reference, and that should work. So now, finally, to make it work, if we go to our little test code here, you can see that we have our position, posx and posz, that we get by default because we're in the getVoxel function. And then we're also handing in an offset and a scale. Now we need those two values and they need to be different for each biome. So the first thing we're going to do is put that in there. So we'll stick a new header up here where we've already got biome name, and we're going to put a public int called offset and a public float called scale. And they're going to be different for each biome. Then we'll go back to our world, and we don't need this now, so let's just get rid of that. So let's get started. Now, basically what we're going to do here is we're going to sample each biome's noise value at the particular point. So in this case, we'll just comment that out until we've got a value. So in this case, let's assume that we have both desert and grass biomes overlapping. What we're going to do is, first off, we need to work out which biome has got the strongest value. So we're taking purling noise samples. Purling returns a value between 0 and 1. We need to know which value has the higher value from that. That is the terrain that we're going to be getting our blocks from. But then the other thing we need to know is what height our terrain needs to be at. Now the way we're going to get that is we're going to add all the heights together from the various biomes. Right now we only have 2, but you could theoretically have 7, and they could and they almost certainly will all overlap in places, even though some of them will have very, very low weights. So what we're going to do is we're going to get a height for each of them, and we're going to add them all together and then divide them by the total amount of biomes at that given point, and then that will give us a height that is smooth between biomes. It also sort of flattens out things because you get the lower weights bringing down the lower heights bringing down the higher heights, but in general it means that you get smooth transitions between biomes in terms of height. And you can do things like you can add animation curves to make it more pronounced, but for now we're just going over the basics. So for these we're going to need a float. We're going to call sum of heights, which is going to start off as 0. We need a count, which is also going to start off as 0. So the sum of heights, we're going to add all our heights together. The count is the amount of heights that we have added, because obviously once we've added 2 values into sum of heights, we've got no way of checking how many values we added into it to get the amount that's there. So count is for keeping track of that. And then we also want to know which one was the strongest, and we're going to do that with 2 values, float, strongest weight, and int, strongest weight index, and these are both going to start off equaling 0. So now we want to loop through all of our biomes. So for int I equals 0, I is less than biomes.length I++, and then in here the first thing we do is we're going to get our biomes noise value. So float weight is what we're going to call it. So weight, because the higher this value, the stronger the weight it is. For people who've played around with Unity's terrain system, think of it as kind of like a splat map-ish, but a very, very, very basic implementation of it. We're going to get that value from our noise function. So noise.get 2D purlin, and we pass in our new vector2, pos.x, pos.z, and then we're going to pass in our biome value that we just added. So biomes, whichever the current one is, offset, and then biomes, whichever the current one is, dot scale. And then to keep track of weight, just put a bit of commenting in here. We're going to say if weight is greater than strongest weight, which the first weight we get will be the strongest because we've set it to 0, initialized it at 0. Then strongest weight equals weight, and strongest biome index equals I. Strongest weight index, sorry. Actually, no, biome index is a better. I was right the second time. Yeah, biome index makes more sense. So then we want to get the height of the terrain. And multiply it by its weight. So to get the height, float height equals, I should be able to steal some code from down here somewhere. Yeah. So this bit here, we'll just steal that. And then where we get these errors here, we're going to replace that with biomes and the index. So that gets us our height for the terrain at this point. And then what we want to do at the end is multiply it by the weight that we got. Now, remember, the weight is a value between 0 and 1. So it's essentially like getting a percentage of it. So if it was 0.8, timesing it by that gives us 80% of whatever the value was. And then the next thing we want to do is, if the height value is greater than 0, because we're not interested in anything that's less than 0, add it to the sum of heights. So if height is greater than 0, sum of heights plus equals height, count plus plus. And then after that, we want to set our biome. So biome attribute, oh, actually we've already got, we'll just use this code here. And then obviously we're setting that to strongest biome index. So regardless of what the height is, the blocks that we choose will be coming from this biome. And to get the average of the heights, we're just going to do sum of heights divided by the count. And then finally, actually, these should be outside of the loop, sorry. My bad. And then finally, we're just going to delete this line here because we're replacing it. Int terrain height equals mathf.floor to int sum of heights plus solid ground height. And that's why we need the solid ground height to be the same for all of them, because we've got this value that we're working so hard up here to keep consistent and smooth between the biomes so we don't get those weird steps. If we then go having this height be different between each one, then we're still going to get those weird borders. So if I go back into here now and I give these a value, and you know what, I've got some pre-made biomes I'm just going to drag across to save messing around with these values because I can't remember what my old one were. So I've dragged these biomes over that I made when I was doing some testing. I'm not sure if you're interested in the values, but that's desert, one that I've called forest, and one that I've called grassland. So I'll just nip into the world here, increase the size of our biomes array, and drag in these biomes. And then if I press play, we should find that our biomes now smoothly transition between each other. Now, as I say, the terrain is kind of flattened out or smoothed off, maybe. It's most of the excessive features, like if you had like a really tall patch from the forest, which I have the forest biome, which I have set to be a bit hillier and have a bit more variation in the land than the desert, which is set to be pretty much flat. It all gets sort of like squashed out to be fairly uniform. But like I say, this is basic biome terrain generation, so we're going to get into stuff like that at a later video when we start to get into the more advanced things. So that is your basic biome generation. I'll just zoom out a bit there. And if I temporarily nip into our textures file and change this so that mipmap is not enabled, we can see everything. Mipmap, by the way, it generates textures. When you get a texture, it generates like a lower resolution texture that can be used for a distance. So it's kind of like level of detail preloading for the texture specifically, but obviously when you're using 16 by 16 textures, there's not much shrinking down that can be done, so it kind of just disappears in the distance. So if you turn it off, you can see all further away, but you kind of get this weird noise effect in the distance. But there we have it. So as I say, the next Minecraft video, fingers crossed, if things don't go all to pot, will be the finishing of the lighting video. I was hoping to do something Halloween themed next week, or I guess this week, depending on, because you'll probably be watching it this week. I haven't decided what yet, but so the next Minecraft video might not be next week or this week, whichever week it is, Halloween week. But it will be the next Minecraft video. Even if that next Minecraft video gets delayed for years. So yeah, that won't happen, by the way. But yeah, so thanks for watching. Sorry about the lighting video. Hope you enjoyed this video. I will see you all next time. Bye-bye. And obviously I can't end the video without saying a huge thank you to my patrons, of which there are now 2. Thank you very much, you guys. You're amazing.